Today we're going to discuss a very important system design interview question, which is design a URL shortener system. So um, you might have seen, you might have got a lot of emails and text messages where you are being given a short link, and when you click it, you are redirected to original URL, right? So that is done by some sort of shortening service, right? So today we're going to discuss and develop and design such type of system. So before going ahead, let's take a step back and understand why we even need this type of systems and what are the use cases. So one of the use cases when a company is running a campaign, they basically needs to send a lot of links of a product page or a YouTube video to millions of users. So there this system becomes very handy because instead of sending a big link, they compress it, shorten it, and send it to user. So they basically optimize that uh, the URLs. So that is one of the use case. Other is affiliate links. Obviously, you have seen where the user specifically wants to hide the original URL and send it to you as some sort of encrypted URL so that you can click it and see where it goes, right? So these are the typical use cases where this type of system is used. Yep. So the system would typically do look like this, right? You given a big URL, it will generate you a short URL, and the user which are using a short URL when they hit into the browser, they should be redirected to the original URL. So this is a very basic functional requirement which we have for the system. So in a typical system design interview setup, which is around 45 to 60 minutes, it is very important you scope down the requirements because you cannot design everything in 60 minutes. So you discuss with the interviewer and come to the consensus where you design the MVP product and both are agreeing on the same requirements, right? So here, when we talk about functional requirements, what we need, given a big URL, it should return me the short URL. As simple as that, right? Now, second important requirement is given a short URL, it should return me or redirect me to the original URL, right? That is one of the other functional requirement. The length of the short URL is 6. For example, here it is 8. So we could say it could be 6 or 8 or whatever, right? Then we need user account for the short URL creation. Why we need user account, right? We want our system to be prevented from anonymous attacks, right? If no one is like it is anonymous, people can abuse it and run some scripts and generate a lot of short URLs, and they can basically exhaust our short URLs, right? So we need some sort of capping on that. So that is where it is better to have user login and that create the URL. For read purpose, definitely we don't want that, but for write, which is creating the short URLs, we definitely want user to log in and that create it. Another aspect is we can somewhere down the line monetize also, right? So based on the limit, if the user is exhausting that limit, you monetize that with certain amount, right? So those are important aspect of product design actually. Then there's a requirement that the user can also give the time to expire, that I created a URL today, it should expire after 15 days or 7 days. uh, then you should have like user should be able to do how many people click on those URLs. So all those analytics you should provide. So this is kind of a simple functional requirements. Let's move to the non-functional requirements. So non-functional requirements are mostly for the non-behavioral changes, right? So this user is not actually directly impacted to it, but somehow at the back end, this is how we need to scale our system and make it more resilient, right? So one first is it should be highly available, right? So when you give a short URL, your system should be always available so that it should basically redirect you to the original URL. So that is one of the very important non-functional requirement. You minimize the read latency uh, from obviously for create as well as for the read, right? It should be scalable, right? Why I said scalable, initially you launch it for 1 million user. Now the user base is increased to 10 million, 20 million, right? So you should not do lot of code changes, right? Instead of, you should have a capability that you can horizontally scale your app servers, you can horizontally scale your DB servers. Data consistency again should be very strong. Once a URL is created and that mapping is stored in the DB, it should not be like inconsistent, right? It should not be for a similar short URL. One user is redirected to a different URL and another user is redirected to a different URL. So we have to maintain that strong consistency. Then we have durability. Obviously, the durability basically here means once you have created a URL, the data should not be um, deleted or somewhere lost. So you have to ensure at the backend that you replicate or scale your system in such a way that those data are not lost basically. Apart from it, extended requirements could be something like you need to have analytics out of it and all those things. But your focus should be mostly on the functional and non-functional requirements. So the second step of the system design interview is the capacity analysis. Again, here you don't have to have the exact numbers. Rather, you should have some ballpark number so that when you're doing your high level design, it would be really helpful to you. So let's do the capacity analysis, right? Let's assume we have 1 million users, right? So in capacity analysis, when I say capacity analysis, we are mostly focusing in two things here. One is what is the storage requirements, what is the QPS of system. QPS is queries per second, or you can say transaction per second, right? So why we need this data? We need this data so that we know, right, what is the hardware we need to install in the application layer, and same at the database layer, how much database storage we need, right? So on a very high level, you give this idea to the interviewer so that you on when you're designing a system, you would be better aware of it, right? Making decisions. So assume you have 1 million users, right? So um, let's suppose you are creating 50 million URLs every month, right? And so what is your write per second, right? It is 50 million divided by this, which comes to 20 URL per second, right? So this is just a write operation, right? There will be read operation as well. So if you see overall system, this is a read heavy system, right? You generate a URL at once, you distribute it to multiple users, and they're gonna use that to get the original URL. So obviously it's a read heavy system, right? uh, so you take the ratio of read to write as 1 to 100, right? So your writes are 50 million per month, so your read would be 5 billion per month, right? So you will have 20 URL per second as a read TPS, write TPS, and 2K URL per second would be your read TPS, because you have taken 100 1 is to 100 as a read and write ratio. So you basically come up with some number of the TPS here, right? So for your read and write APIs. Then let's move to storage requirements, right? Since we've already seen that we would need, let's do the storage analysis for let's say 10 years, right? So um, let's say you have 5 million every month, right? So it comes to around 600 million, right? And each storing the data and metadata for each URL takes 10 KB, so it comes around 6 TB. So this is your the basic storage requirements on your database side. So what we did in capacity analysis, we took some user base, we identify what is the QPS of the system and what is the storage requirements of the system, right? Okay, fine. Let's move forward from here. So third aspect is now you're gonna deep dive into designing your system, right? So how your system would look like. So one of the important aspect is your API design, right? So uh, any system would work on APIs, right? So you would expose some sort of REST APIs where your front end system would be using those and getting the data, right? For read, write, and all those CRUD operations, you will need some sort of APIs. So if you see overall system, right, what we are doing, we are taking a big URL, right? We are compressing it and we are returning a short URL, right? So here there are a lot of different algorithms where you can use to encode your data or shorten your data. One is base64, base62, MD5 hash, and all those things. I'm not going in details about these algorithms, but definitely what it will do is basically it will encode your data right into base64. For example, here um, we take this large URL. When it runs through a base64 encoder, it will generate a base64 string, right? So uh, what we would do is we would take the first six characters of it, right? So someone can say, hey, if you're taking first six characters, there's obviously chance of collision, right? You could send multiple duplicate URLs to the user. That is correct. But we will see how we'll tackle this use cases in the design. But if you analyze, right, even if you take six characters, it would you have 64 combinations for one character, right? Basically, we are taking base 64. So you have A to Z, small a to Z, small a to Z, and then you have 1 to 12, right? So total you have 64 characters, 54 combinations for one character. So if you see you can even for six letter URLs, you can generate 67 billion short URLs, right? Again, the question of duplicates, we'll see how we'll handle it at the app layer. But this is a very high level design on how we are basically generating a six letter URL out of long URL. So if you closely think, what are the APIs, right? We are writing something, we are creating a URL, and we are reading a URL, right? Um, so if you see you would need a create URL where you would need an access token. I'll discuss why we need an access token. Then you pass in the big URL. Um, if the user pass the expiration time, it would be taken that. Else, we'll default take it as 30 days. Then you have customize. So user can also ask that my short URL should be prefixed with certain aliases, right? So those are again, it's an optional parameter. So why we need an access token here, right? So access token we need here is as I discussed, right? So uh, we want user to create URLs only when he's when he's logged into the system, right? When he's logged into the website. Why we don't need anonymous users to create URLs, because they can then we don't have any control, and there could be a lot of anonymous attacks which are exhausting and creating a lot of fake URLs which actually they are abusing the system, right? So that is where we need a user, and we are forcing users to first log into a system and then only they can create it. So when they log in the login API, they will get an access token that they have to pass into this API. I definitely don't want to go into the login API details because that is very trivial, and it's not related to design for this particular system. So similarly, we have get URL. In get URL, you basically have you'll pass in the short URL, and this API will query the database and get you the original URL. Then similarly, we have delete URL. So if user want to delete the short URL before even like they're not expired, then they can use it these API. Then obviously we have login and logout API just for the use cases where we want to create the URL. So login logout would not be used for read users obviously. So for read use cases, they would be just needing the short URL which they'll type in browser, and they'll be redirected to the original URL. So let's look into the DB design. So a DB design should be in line with what our API design is, right? So basically you should ensure that whatever your APIs need, you should get it from database. For example, in the create flow, right, you basically need to store the mapping. So you'll be given a big URL, you convert that big URL into a short URL and you store somewhere in the database, because that would be needed during the get operation, right? So this is the table which would be storing that data. So tiny URL would be the URL which we have generated, thus the compressed URL. It would be mapped to original URL, and then we have created an expiration time, all those things. So why we have taken primary key, tiny URL as a primary key, that will I'll discuss in the later part of this video. And this is a very important aspect to avoid duplicates, and how it is used. I'll definitely need to go through it in detail. So this is one mapping which we need. Another is obviously user ID, like who is the owner of that, because when they want to delete it, it should not be like um, anyone can delete any URL. So only the owner of that URL can delete it, right? So let's move to the next part. So let's build the MVP. When I say MVP, you always build a system in with minimal resources. Like you have just one database server, you have just a single app server, and you build your product, right? That is MVP, and which is called minimal viable product, right? You make it functionally working, right? And then as in when your user base increases, you scale it up, right? So what is the usual flow is that user will log in and they will call the create URL API. So this API will create a base64 of the long URL. It will trim it down to 6 characters, and then it will try to store that into DB. So there are two cases. Either that trimmed 6 character is not used till now, like no one has used till now, or the second use case is already we have already created that short URL for some other URL. So in that case, it would be a duplicate, right? So since we have taken uh, tiny URL as a primary key, so in that case, the create operation will fail, right? So in that case, what we have to do, the API will keep on retrying until it find a short URL which is unique. So that is the reason why we took tiny URL as a primary key, so that we can leverage that primary key violation from the database itself to design a system. Because um, for any given URL, right, it should be mapped to a unique URL. It should not be like user one is giving a URL, right, and it is mapped to same URL which user two is giving. So for any given long URL, there should be only one and one uh, short URL. So that is where we need that primary key violation condition here, and let the API system, let the app server keep on retrying it till it find a better uh, short URL which is unique, right? So this is kind of MVP. So if you see here, right, what we do in the create URL, you take a big URL, right, and then you do a base64 out of it. You trim the base64 string. You take the 6 characters, right? Then you try to write into this database table. Now, if someone has already taken the tiny URL, right, you won't be able to write it because it will give you a primary key violation. So in that case, your app server will keep on retrying to find a unique 6 letter key which is not used till now. So that is the most viable product in terms of minimum resources. So you make ensure that you always start with first building such use case and then later scale it up. Now, since we have built the MVP, let's try to scale our system and see what are the problems we have in the MVP design and try to address them. So if you see, one of the problem is that there is a single point of failure. So we have taken a single application node. So if that is that has gone down due to deployments or security patch, so our whole system becomes unavailable, right? So we cannot afford to have that such system. Second is, as in when the user increases, there will be more read and write queries to application server, right? So a single host cannot sustain that load because it has its limitations of supporting 200 to 300 connections at a time. So other connections have to wait in queue and they will eventually time out, right? So we have to think of how we can scale up the system. The same goes with the DB, right? Suppose if you have taken a DB server and its hard drive crashes, right? So you have basically lost all your data. So you don't know now what is the mapping between short URL and long URL. So eventually your whole system uh, is down, right? And there is no backup you have taken, so eventually you have lost all your data. So this is definitely not um, uh, acceptable as per as durability concerns. Right? So let's see how we can scale up the system. So this is what we have done, right? So to solve that single point of failure, we have added more application nodes. So we have added more hardware, the application level. So even if one host is down, there are other hosts which can still take the traffic and make the system available. Same goes with the database server, right? So what we have done is one of the problems we have in MVP is we can lose all the data, right? If the database hard drive is crashed. So what we have done is we have taken a typical master slave architecture where we have write and read replicas. So your data from write DB will be replicated to the slave nodes. So what will eventually happen is that all your write queries will be coming to the write DB and they will be replicated to the read nodes, right? So how it is basically solving the problem. So suppose if the write one of the node is down, let's say the master node is down, which is the write node, right? In that case, what will happen is one of the read nodes will become a leader and it will act as a master. And since we have replicated all the data to the read nodes, so we haven't lost the data. And again, if any of the read nodes is down, it is okay because we have multiple read nodes which have all the data. So we have solved the problem where we were having the data loss in the original MVP design. The second problem is the if you see the overall system, it's a read heavy system. It's a read heavy system. Why? Because um, um, if you see take an use case, right? So where user creates an URL. After he creates a URL, definitely he'll pass to multiple users, right? So they will basically try to get the redirected original URL. So definitely it's a read heavy system and how you will support that access pattern. So what we have done is we have one write node where the writes will be going and the data would be replicated to the read nodes and all the queries will be redirected to the read replicas. So if you see in our API design, right, we have two APIs, create URL and get URL. So create URL is the API which is creating the URL and writing into a DB, and get original URL is the API which is from the short URL it is reading and getting you the original URL. So obviously the get URL will be called by a lot of users. So there we have basically read replicas to support it. So here we in this scaling up design we have solved two problems. One is single point of failures and support read heavy access pattern at the DB layer. So let's now try to think what are the other problems we have in MVP design and how we can solve it basically. So if you see, right, one of the problems with the MVP is that uh, what we are doing, right, we in the create flow, when the user is giving a long URL and expecting a short URL, it will call the create API. So create API will internally do the base64, trim the base64 string into 6 character and try to store that into DB. So if that short URL is already present in the DB, it will throw exception and at the app layer will keep on retrying, right? But what is eventually happening is that the end user is still waiting to get the short URL. So in the worst case, what can happen is that he's still waiting and after 5 6 retries you are giving that data, so latency would be very high. And in the worst case, it can happen that even after 5 6 retries you're still not able to find the unique or URL and you have to return 5xx, which is obviously not a good user experience, right? So how you can solve this problem So what we have done is we have taken a simple key generation service. So key generation service responsibility of this would be basically um, to have it readily available, the short URLs, right? So um, the key, whenever you call a key generation service, it will host few APIs, and whenever you are calling this API, it will ensure that it will return you the unique URLs on the fly. And in the backend, in the asynchronous process, it is keep on generating the short URLs and storing that into its DB. So the typical flow would be the create URL is called. It will call the key generation service and it will get the unique URL, and then it will store that into database. Now we have removed that bottleneck where we are keep on retrying to find the unique keys, because we have delegated that responsibility to a key generation service, which is asynchronously creating those keys and storing that in database. So in the real time path, when the user is coming and creating the URL, it doesn't has to wait for find that unique URL, right? So we have optimized the latency of create API, as well as the user experience is better, because if you see in the MVP design, the problem was, in the worst case it can happen that you cannot find the unique URL and you have to return 5xx. But here you ensure the key generation service will ensure that you always get the unique URL always, and it will return you to that application server. So that end user will always get the unique URL. So this way we have scaled it up a little bit more. Let's try to see what other optimizations we can do. So if you see in the read API, once you do a database call to get the, or like you will get, so what is read API, right? Let's revisit this. So read API is you get the tiny URL and you give me the original URL, right? So in the MVP design, what will it will do? It will call the database, it will got the original URL, and it will return to the user. Now we want to optimize it, right? Because you don't want to hit the database every time, because your mapping is not changing, right? No one is going to change your mapping eventually. So what you can do is you can introduce a caching layer, right? So as soon as you get a read query, you uh, so as soon as you get a short URL, you query into the cache, and if that original URL is present in the cache, you return from the cache. If not, you do the database call, and in the return in the async thread, you update the cache as well, so that for the subsequent calls, you um, validate that, like you get the data from cache. So eventually, in every read call, you are not hitting the DB servers. So overall, you are basically optimizing your read API latency. You also have to ensure how you manage the TTL, because maybe based on your either your expiry, whatever is the expiry of that link, you to maintain the TTL. It should not be that you have taken a large ETL, even though that your short URL is expired, you are still returning that response. So that fine tuning you have to done. So we have come to an uh, end of this system design problems. So this is how you basically have to cater in the system design interview. And the first step, let me try to revisit it. You come with the functional requirements, you discuss with your interviewer what is the functional, non-functional requirements, you come to the consensus, and you document those, right? Um, then you do a capacity analysis, like what is a QPS uh, I would need to have in our system. What is the memory storage I would need in TBs? You take any ballpark number of the number of user, started with 10 million, 100 million or whatsoever, right? Then you come to the API design, right? Because once you do the API design, you will have more clarity how you have to design your system. You will get the read and write pattern, and then accordingly you will scale up and scale down your system. And after that, don't try to jump into the final solution. Try to first build the MVP, where you discuss it with your interviewer that uh, I have a single DB instance set up, and I'm functionally my system is working fine, right? Then try to find problems. What are the problems with this? Scale it up one by one. So once you have scaled up, try to have microservice architecture into your system and see what responsibilities you can segregate so that your latency is optimized, and see what where if there is any possibility to introduce cache in your system, right? You can do that. And finally, once you have done all this, you need to wrap up, but there will be still open questions like how would you ensure the observability of your system, right? There were some requirements related to analytics, like for example, user want to know how many users basically clicked on his short URL. So all those analytics also you can have in your system. So what you can do is, you can, as soon as you get a read request, you push that event in your queue, and then it is consumed and put into Elasticsearch server, in Elasticsearch cluster, where basically you can build all the indexes and provide those dashboards. So these things you will discuss, but this obviously should be parked at the end, so that once you are build up your MVP scalable and optimized system, then you will come to the extended requirements. So that's all from my side. Thank you.